Precalculus mid third, 9 weeks, common assessment 2019-2020. Here we have 20 problems on basic trigonometry from chapter 4. Problem 1, the measure of angle C is 45 degrees. What is the measure of angle C in radians? A number of different ways to work this problem. The one way I prefer is if you understand or remember that 180 degrees is equivalent to pi radians. What happens is we can convert this 45 degrees into radians by multiplying by pi over 180 degrees. Now, how do we know that we divide by 180 instead of multiply? Because we have to set up the proportion so as to cancel out the degrees. We do that, we get 45 1/80ths times pi, and 45 1/80ths simplifies to 1/4 of pi, or pi over 4. Also, if you look at the unit circle, we see the equivalency here on our unit circle. So, A is our correct answer. Next, 2. Theta is the angle of inclination of the drawing shown below. Which answer has the closest measured angle theta? Well, we're given the two sides of this right angle here, and this 700 feet is our opposite side of our triangle, and the 500 feet at the base is our adjacent. So which trigonometric ratio involves opposite and adjacent? Well, it's going to be tangent. So tangent theta is equal to opposite over adjacent. So I put 7 over 5. Why do we got 7 over 5? Well, that's because I know 700 divided by 500 is 7 divided by 5. So how do we isolate this? Well, if we take the inverse tangent of the equation on the left side, inverse tangent of tangent cancels out to be theta. And the right side we have inverse tangent is 7/5. And we go to our calculator, and the first thing I notice, I'm ready for things like this, is that what units of angle measure do we have here? Radians. We are asked our questions in degrees, so I'm going to go to mode and go down here, change this over to degrees. Now we're in degrees. And so go out of here, and we have inverse tangent, second tangent, and we're going to go 7 divided by 5, and we get 54.5 degrees to the nearest tenth. Approximately. So 54 degrees to the nearest full degree. That's as close we get. Let me see, I round it up. What should it be here? Yeah, but rounds up like that. But if we were looking to the nearest degree, we would run down to 54. Okay. Good. Next, 3. The Chrysler Building in New York City was the tallest building in the world at the time it was built. It casts shadow approximately 130 feet long on the street with sun rays. So form a 82.9 degree angle. So what we have is this. We got our Chrysler Building right here. We got our sun's ray coming up here. Here's our sun. And then we have an angle coming down here, hits the edge of the building, goes on down, straight to the earth. So there's the shadow right here. And that shadow's length is 130 feet. So 130 feet. Somehow I went to the other pen. Anyway, and this angle here, cast a shadow, forms an 80 degree with the earth. How tall is the building? Well, here would be angle here with the earth of the, okay, the ray shadow. That'd be 82.9 degrees. So we have is the height of our building. So we have the tangent of this angle here, 82.9 degrees, equals the height of the building over our adjacent side, which is 130. And by the way, this height will be our opposite side. This 130 feet down here would be our adjacent side. So height is going to be equal to 130 tangent 82.9 degrees. So go to our calculator. We get 130 times tangent 82.9 degrees. That's what it is here. So we get 1,044 feet round the nearest foot. Okay, yeah, the closest would be this one right here, 1,043 feet. C is kind of close too. Usually don't see the answers that close. I don't know if what we're trying to do here with that. Okay, yeah, so that's as good as we can get here. Next, 4. The car goes up slant, length 400 feet as shown. So here we have again a right triangle, and we have we'll find our angle of inclination. Our angle of elevation will be this thing right here, this angle right here. And for this particular angle, our 60 feet over here is going to be our opposite side. Our 1,000 feet over here is going to be our hypotenuse. So opposite over hypotenuse, that's, what is it? Sine. So sine theta equals our opposite side, which is 60 divided by 1,000. And then we can cross off these zeros here. So 0.06. So our theta, we're going to take the inverse here, is going to be equal to the inverse sine of 6 divided by 600ths is 0.06. So theta is going to be equal to, under our calculator, inverse sine of 0.06. Here we have, make sure we are in degrees. Yes, we are. 3.44 degrees. And that's going to be closest to answer choice B. Next 5. A guy wire from the top of the transmission tower at WGBC forms a 75-degree angle. Here we have a drawing. And we're trying to find about the height of the tower. So this is back to our Chrysler building problem, pretty much, right? We have a height here. So we have tangent of this angle here, 75 degrees, is equal to our height over our adjacent side, which is 55 degrees. So height is going to be equal to 55 tangent of 75 degrees. And so height is going to be equal to, and again, this is our 55 down below is our adjacent side. Our height is our opposite side. So height 55, tangent 75 degrees. We are in degrees here. Enter 205.3 feet. So, what is going to be our best answer? Answer choice C. Next, problem 6. The arc of a circle with a radius of 12 inches has a length of 23 inches. To the nearest degree, what is the measure of the angle that describes the arc of the circle? Well, the arc length formula is S equals R theta. And we want to find the angle, and so angle is equal to, if we divide by R, to arc length divided by radius. And so our arc length is 23 inches and our radius is 12 inches. But that will be in radians. So to find the measure in degrees, if we multiply this by 180 over pi, we will have it. So 23 times 180 divided by 12 pi. Divided by 12 pi. And there it is. Oops, wrong one. What is it? Okay. Second. Did I get it right here? Man, it's the same thing. Oh, there it is. There we are. Okay. So 109.8 degrees. Closest answer, C, 110 degrees. Next. 7. For the right triangle shown below, what is secant theta? Well, secant theta is equal to the reciprocal, or 1 over cosine theta. So if we can find cosine theta, a cosine is our adjacent over our hypotenuse. And by the way, secant can only be, absolute value of secant has to be 1 or greater. So A and B are just automatically disqualified. So what is our cosine? Theta is equal to 5 over 20. And so that's going to be equal to 1/4. Well, secant is our reciprocal, or 1 over 1/4, which will be 4 over 1, which equals 4. So that is our secant value. 4. D is our correct answer, number 7. Next, 8. Solve for the unknown to the nearest tenth. Okay, we have an angle here, right angle. Opposite our angle 35 degrees is, that's our opposite side. Y is our hypotenuse. So which trigonometric ratio involves opposite and hypotenuse? Was going to be sine. So sine 35 degrees is equal to our opposite over our hypotenuse. So there are different ways to do this. One way you can do this is y over 29 is equal to 1 over sine 35 degrees. So if it cross multiply 29, y is equal to 29 over sine 35 degrees. And if we have our calculator in degrees, which we do, make sure I got this right here, 29 over sine 35. Okay. 29 over sine 35 degrees. 55.6, I guess, rounded there's 10. 55, 29 sine 35 doesn't look right. Huh. 50.6. I'm mistranscribing. Okay, 50.6 units. Okay, that's it. D. Now, for an angle measures 5 pi over 4, and that's going to be radians, in standard position, what's the value of its reference angle in degrees? Number of ways you can do this. One way is to convert this into degrees. So if we take, or we could subtract out pi, but let's convert this to degrees. 5/4 pi. To convert this in degrees, we multiply by 180. Times 180 over pi. So pi over pi cancels out. So we get 5 times 180 over 4, which is going to be 5 times 45, which is going to be 225 degrees. And we, with 225 degrees, find ourselves in quadrant 3. So our reference angle is to be found by taking 225 degrees, our measurement in quadrant 3, subtracting from it 180 degrees, so we get 45 degrees. Now, to have a reference angle, we have to have a positive acute angle. So it's going to be D is, and A is not automatically disqualified, but maybe unlikely. Our correct answer is C. Next, 10. A circle has a radius of 2 miles. What is the length of the arc? Has a central angle measure of 2 pi radians. Well, again, we have this S equals R theta, and this works in this form if we are in radians, which we are, 2 pi radians. We have a radius. So basically an arc length is radius times radians. And that's going to be 2 times 2 pi, which is going to be approximately 6.28 or 6.3. Put that in your calculator. 2 times 2 pi. No, it's going to be longer than that. It's going to be longer than that because, so let's just go ahead and put in our calculator. Because 2 pi is 6.28. 2 times 2 pi is going to be this guy right here. So let's go 2 times 2 pi. Yeah, about 12.6. That's our answer. 11. What's the expression for angle theta? Well, let's just look at this. Okay, we have our theta here, and our tangent is our opposite over our adjacent, so that the tangent of theta is equal to 29 over 36. So we solve for theta by taking the inverse tangent of both sides. We have theta is equal to inverse tangent of 29 over 36. So our correct answer for this one is A. Now, people ask me about this. Well, the value of the tangent, okay, tangent theta is equal to 2936, but angle theta itself is going to be represented by answer choice A. And we can figure out what that angle measure is if we want to, right? Take the inverse tangent of it. But that's it. Okay, 12. Measure of angle M is 37.25 degrees. What is the measure of angle M in DMS? Well, DMS stands for degrees, minutes, seconds. So what we would have here is we would have 37 degrees, and then we have plus 0.25 degrees. Well, how do we change this 0.25 degrees? Well, we have to remember that 1 degree is equivalent to 60 minutes. So we got to take this 0.25 and multiply it by 60. And when we do that, we're going to get, and that'll be minutes here because it'll be 60 minutes per degree. So degrees over degrees cancel. And what we're going to get for that is 0.25 degrees 15. Is that right? Point 0.25 times 60. 15, yes. So that's going to be 37 degrees. 15 minutes. That's it. And I guess like you have 15 minutes is a quarter of an hour. So you can analogize the minutes in degrees as you could with minutes in an hour. And also seconds an hour. 13. John stands atop a cliff 150 feet above sea level. He looks upon a small boat quite a ways off and measures the angle of declination, or angle of depression, you could say, to the boat. What is the horizontal distance from John to the boat? Drawing not to scale. So we want to have this distance here. And that is our distance D. And what we have here is, this will be 3.5 degrees. So we could write this as a tangent. Tangent 3.5 degrees is equal to 150 feet over distance D. Now, one thing you can use here is if we find what this value is here, if we take 90 minus 3.5, you're going to get 86.5 degrees. And this is where cotangent comes from because it's the tangent of its complementary angle. So the tangent of its complement, which is 86.5 degrees, is going to be equal to D over 150. So what that does for us is we can write this as D equals 150 tangent 86.5 degrees. So D, and go into our calculator, 150 times tangent 86.5 degrees So we get 2,452 feet. And that's answer choice D. Next, 14. A spectator theater looks up to the top of the curtain on a stage. It makes an angle of inclination or angle of elevation, that's another word for inclination, of 21 degrees above horizontal. So here we have a curtain over here, whose height, we have a spectator whose eye is right here and looks up here at the top of the curtain. Okay, so there we go. And this angle of inclination is 21 degrees. We have the height of the curtain is 12 feet. So that's 12 feet right there. And it says, how far away from the curtain is the spectator in the nearest 10th foot? So here we have, again, the distance here. So again, it's a tangent situation, because a tangent of 21 degrees is equal to 12 over the distance. We can work this again a number of different ways. One way to do that is we can write this as just flip each fraction upside down. We can have d over 12 equals 1 over tangent 21 degrees. So what we have is we cross multiply 12, d is going to be equal to 12 over tangent of 21 degrees. So we go to our calculator, d equals 12 over tangent 21 degrees. We're in degrees, good. We get 31.3 feet. So D, 31.3 feet. And that's going to be answer choice B. Okay, next, 15. An owl is perched atop a 40-foot tree. There is a mouse at an angle of inclination to the owl of 40 degrees. To get the safety from the predator owl, the mouse needs to reach a hole that is an angle of inclination at 35 degrees to the owl. So there's 10th foot. How far must the mouse go to get to the safety of the hole? So we're interested in this distance between the mouse and the hole. What we can do is create two triangles, first of which could be this one here. And we could call this distance y. And then we can make a second triangle using this distance here, which we can call x. So our distance will be x minus y, if we can find what those are. Well, there are, again, a lot of ways to do this. One way to do this that I like to do is take this 35-degree angle here and subtract it from 90 to create its complement, which is going to be, let's see, 55 degrees, is that right? Yes. And then this 40-degree angle, its complement is going to be 50. So basically what we have is this distance between them is going to be 40 tangent of this bigger angle minus 40 tangent of this 50-degree angle. And also you could just do 40, factor out the 40 times quantity tan 55 minus tan 50 degrees. And that's going to be equal to x minus y. So here we go. 40 tangent 55 degrees minus tangent 50 degrees. We are in degrees here, and that should do it. 9.46 feet. Which is going to be closest to answer choice A. 16. The law of sines may be used to find the side length of angle of a non-length or angle of a non-right triangle according to the equation being used well for side C. What is the length of side C? So basically what we have is this equation here. And in chapter 4 we haven't gone to law of sines yet, but this is kind of a preliminary question that we can still solve. If we cross multiply the sine of 41 degrees, C is going to be equal to 72.5 times sine of 41 degrees over sine of 94 degrees. So C is going to be equal to, for a calculator, if I can remember here, 72.5. Sine 41 degrees divided by sine of 94 degrees. I hope this is it here. So about 47.7. 47.7. Answer choice A. 17. Which pair of angles, angle measures below in the answer choice that represents a pair of coterminal angles? Basically, for coterminal angles, we're looking for angles that are 360 degrees apart. I mean, if we're in degrees. Now, 2 pi radians if we're in radians. So we can, for instance, take answer choice B. If we took 450 degrees minus 45, and we got as our answer 360 degrees, that would be evidence of a coterminal pair, but we get 395 degrees. They are not 360 degrees apart, not a correct answer. Now, on the other hand, for this 270 degrees, if we subtract out negative 90 degrees, we're going to get 270 minus negative 90 degrees is going to be 360 degrees. Or you can look at it like if you take negative 90 plus 360, you get 270 degrees. So that's it. These other ones are not. This D is choice D. That's 330 apart. These choice A is 180 degrees apart. Next, 18. The arc of a circle has a central angle of 100 degrees. What is the length of the arc if the diameter of the circle is 14 inches in length? So basically what we have here is S. Now I'm going to save my room, use my room here. S equals R theta. And we're in degrees. So to change this already, if we multiply this by 180 over pi, okay, we would have it was the length of the arc. Okay, so we take S is going to be equal to our radius. Well, our radius is going to be half of our diameter, so that's going to be 7 times 100 degrees, and we're going to convert that into radians. I had it backwards, didn't I? degrees, we go times pi over 180. There we go. Times 100 times pi over 180. And basically, now we know that 1 radian is 57.3 degrees, right? So if we had 7 and an angle of 57.3 degrees, we would have 7 inches of radius length, right? So we're going to have 700 times pi over 180. Divided by 180. And we get 12.22. It's inches. Now, it says to the nearest tenth, right? What is the nearest tenth? That's going to be this first decimal place, so 12.2 inches. So we put 12.2, so 12, 1, 2.2, and there we have it. Okay, next. An angle in standard position measures 330 degrees. What is the measure of its reference angle in degrees? Well, basically, we're talking about a quadrant 4 angle here at 330 degrees. So what we have to do to find a reference angle is take 360 degrees, a full angle rotation, and subtract from it 330 degrees. Basically, what we're looking for is the smallest positive angle to the x-axis. So that's going to be 30 degrees. And then we're going to mark this as 30. I'm going to show you on a unit circle what that looks like. So 3, 0. Okay, let's look at the unit circle. So here we are at 330 degrees. Well, the reference angle is going to be this angle here between the x-axis and this. So we don't go, instead of going all the way around with a reference angle, we just go the shortest angle, positive angle to the x-axis, which is going to be 30 degrees. Last problem, 20. Well, the shadow length of the church measures 120 feet. So here's our shadow length, 120 feet. Okay, what is our height? What is the height of the church is what we're being asked. Well, the tangent of this angle, which is 55 degrees, is equal to the height over the adjacent side, which is 120 feet. So height is our opposite. So we get is 120 feet, yeah. So h is going to be equal to 120 tangent 55 degrees. So h is going to be equal to, and we're going to the nearest tenth of a foot. Okay, let's remember that. 120 tangent 55 degrees. We get 171 point to the nearest tenth. That's 0.377. That rounds off to 0.4. So we'll say 171.4 feet. So there's 10 foot. So 171.4. And here it is, 171.4. It shouldn't have been too hard of a test, but it does cover a lot. Really suffices for, I hope, Chapter 4. Good luck, and thanks for viewing.